So this is going to be question number 5 on the discussion. It's called infinite hailstone. And so what this function is going to do is we're going to have once again, the topic is generators. And so we're going to have a generator function that outputs like a hailstone sequence starting at number n. And once we reach the value 1, we go on forever. And so here's the hailstone sequence of how it works if you don't remember. If n is even, divided by 2, n is odd, times 3 plus 1. And then when n is 1, we want to keep yielding that number. And so in this case, here's a little doc test. We put in n for hailstone 10. And calling hailstone of 10 is going to give us a generator. And what we're going to do with this generator is that we're going to yield elements from it. So we're calling next of hailgen. So the first element is 10, then the second is 5, because it was even, divided by 2, then 16, odd, times 3 plus 1, then divided by 2, divided by 2, divided by 2, and it hits 1, and then we're going to keep on yielding 1 once we've hit 1, the end of the sequence. And as you can see right here, we call next of hailgen again, it's going to return 1, because it's going to do that forever. But yeah, so this should be pretty similar to the recursive or like iterative way of doing hailstone, except it's like generators. And so you might imagine you printed, if you remember, you like printed out the number each time with the iterative and the recursive solution back then in like the earlier discussions. But in this case, we're actually yielding elements this time. So take a little bit, remember how you did your recursive calls or like iterative calls, and we'll like go over this. But yeah, let's get started. And so starting out, let's say we want to implement it, recursively maybe. And so how this is going to work is that so let me write it out how we used to do it earlier. So we did like print n. So we're printing out the number n. And so in the case of like hailstone of 10, it would like print out 10. And then we had like two cases, right? And so first, if it's even, and then if it was odd. And then so if n mod 2 is even, so if n is even, then what are you going to do? We're going to call hailstone of n divided by 2. And I put floor diff because it gets rid of like the 0.0 at the end. And then so if you might imagine, what happens is that if I call hailstone of n divided by 2, what's going to happen is that it's calling it on 5, and then calling hailstone on 5 is going to get all the other elements. And so hailstone n divided by 2 is handled, and then otherwise, in the else statement, we do the opposite. So hailstone n divided by n times 3 plus 1 maybe, if it's odd. And then so yeah, this is kind of going to be a structure for our generator. And so prints, you can imagine like the prints are like pretty similar to like yields in a generator. And so whenever you print n, you essentially want to yield that value. And so let's actually change it to a yield right here, yield n. So just one small change right here, and we'll see how it like plays out. So we yield n, and so when we call hailstone of 10, we end up yielding the number 10. So we give the number 10 to be yielded, and as you can see, that's where the 10 comes from. But we need to handle like the 5, 16, 8, 4, 2, 1, 1, etc. And then, so how are we going to handle that? Well, pretending like once again, like this idea of like the recursive leap of faith, pretending that our recursive calls work, let's assume that hailstone of n divided by 2, so hailstone of 5 is going to give us all of these numbers. And if you might imagine, it would have numbers past that 1. It would have like an infinite amount of 1s. And then so since it handles everything else, we can yield all of those elements from that hailstone recursive call. And how do we yield all the elements from like a generator or like an iterator? We're going to use like the yield from keyword. So yield from hailstone of n divided by 2. And on the other hand, same idea. If it was odd, we would call like hailstone of 16. And in 16 would handle, hailstone of 16 would handle 16, 8, 4, 2, 1, 1, 1, 1, 1 forever. And we can continuously yield from that. Yield from hailstone of n times 3 plus 1. And yeah, so this is like the recursive call for hailstone of n. But one thing we need to handle is like the n sequence. And then so, how are we going to handle the n sequence? And then so, how we're going to handle this is that we need to add another condition. Because like if n is 1, we don't want to be dividing by 2. We don't want to be like multiplying by 3 and adding 1. And so let's add another condition for if n is 1. and then we'll put like an elif right here and all of that. And then so the question here is, what do we want to put for if n equals 1? Well, what hailstone sequence? So let's say we call hailstone 1, right? And we yield 1. And then what are the values that we want to yield after that? Take a little bit of time to think. And yeah, and so it turns out that once we yield a 1, so we yield this one, we want to yield 1s forever. And so question is, what is our recursive call going to be to handle that? Because, I mean, we could do this, so while true, yield 1. And so that would work, but let's say we can't use like a while loop. So we can't have this like forever while true, yield 1. And so how we're going to handle this is like, think about what called a hailstone of 1, I gave it away. What called a hailstone of n is going to yield 1s forever. And it turns out is hailstone of 1. And so hailstone of 1, and we're going to yield from hailstone of 1. So it's kind of odd, because what happens is that we call hailstone of 1, and then it's going to yield 1, and then it's going to yield from the same recursive call. And so what's happening here is that, like, it's kind of confusing, but what happens is that we yield a 1, and then we ask the other recursive call, hailstone of 1, to yield all their values. And then so that hailstone 1 call is going to yield a 1, and then once again it's going to ask from another generator, hailstone of 1, yield from, like, give me all of your values. And so it's going to be a little chain of like each hailstone of 1 call is going to yield a single 1, and then it's going to make a call to like hailstone of 1 to get the remaining values. So it's kind of like making like a ton of generators every time you like call next of like the sequence. But yeah, and so I think this should be it. Let me check. I'm not exactly sure. Maybe I messed up. But yeah, okay, it seems like it's good. And so yeah, I went over the recursive solution, and now I'm gonna go over the iterative solution. And so yeah, I'm gonna delete this real quick. Actually, I'll keep it. But the iterative solution is actually like pretty similar. And so the idea here is that like while n is not 1, we kind of want to go about doing things like usual with like, and so in the old like solution without like generators and all that, where we like printed everything out, we did like while n is not equal to 1, then we're gonna like yield n, and then we have, we're gonna like print n, but in this case, you know, we're a generator and we want to be yielding things, so we're going to be yielding that value. And then we go into like the two conditions. So if n mod 2 is equal to 0, then we're going to like change n, so n gets halved. And otherwise, if it's odd, then we want to be dividing by multiplying by 3 and adding 1. And so notice how alright, I'll comment this out, but notice how we don't even care about like the infinite ones, because this condition is going to handle everything until we hit that 1. And so, you know, 10, we're going to yield that 10, n is even, so it's going to become 5, and we're going to yield that 5, comes to 16, yield that 16, etc. And then it hits 1, and we exit out of the while loop. And then what do we want to do after that? Well, we want to keep on yielding 1s forever, and I kind of like typed it out here earlier, but if we want to yield 1s forever, we want like a while loop that goes on forever, and so we should have like a while true condition. So while true, it's always true. This is going to go on forever, and what do we want to do? Yield 1. That's an indent. And so yeah, and the reasoning behind this is, and I guess what I'm trying to say is, you know, you see a while true, you might think that's an infinite for loop, but remember like infinite iteration or something. But remember that in the case of generators, we're only going to yield values. We're only going to run code until the next yield. And so generators are going to work perfectly fine with like infinite loops if we yield things inside of it. So we call next on this generator, and it's going to be yield 1, and we're going to stop right there. We're not going to keep on going through the, you know, infinite loop, and so we are good to go. And yeah, this is going to be all of Infinite Hailstone. And once again, if you have any questions, feel free to let me know. And yeah, hope you have a great night.